Hello my friends, nice to meet you again with our video series for ladder logic programming. And last time we was saying we have completed the project for a dual compressor because the requirement was to organize the operation between the two compressors to have or we have got a requirement from the client, and the client told us we need to manage to have one of those compressors to work at a time, unless we have a heavy duty operation, so we need both of them to working. Considering working one at a time and switching between most of them based on the cycle, like if A working for this cycle, so the next cycle it will be, and then the next cycle will be A, and so on. And if we're going on a heavy duty cycle, so we need to have both compressor working to compensate the requirements or the demand for the gas and to maintain the pressure here. And we have talking about the component, like we have here the compressor, and we have a sensor to measure the pressure inside the tank, and we have one on the right, one on the left. So the one on the left to working the process, and we have used the other one for detecting the heavy duty range. And then we managed everything for having indicators and the actuators. Everything was working fine here. But why we come back to in this session with the same project? Because I want to tell you in a practical manner that you might deliver your project, and your client return back either with a fault in the project or a bug, and you need to fix some logical error in the program, or with additional requirement. And that's what happened today. The requirement call the client come back to me with a new requirement, and he told me, oh yeah, yes, everything is okay, and it's the requirement is that I asked you to do working perfectly. But actually, after we testing the system, we came through something which is not considered from us. That's why we didn't tell you about it. But and we need it urgent, because that's very important. I told him what is this. He told me because we have managed to if we are not under the heavy duty, so we working with only commanding one compressor to work, and then after cycle is done, the other compressor will work, and so on, for saving the high the overload, preventing overload on the compressors. But the question is, if the cycle is not to end, so what is the problem? If the cycle doesn't end, that's a problem, because the compressor will working forever without switching to the other one, because the other one is waiting for the next cycle, and cycle go forever. But how the cycle go forever? Yes, because that's the situation. Like when we have one compressor working, so that compressor has a power, or has the value of its power equivalent to the amount of pressure they can push into the tank. So if the flow was open to a large value, at which the pressure pushed by this compressor which is running is not enough to increasing the pressure, so the cycle will continue forever, and this compressor will working for a very long time, and that's not convenient, because compressor now working under a risk to be damaged or not working. So let's first show you the condition. Like if I have this one, I requested to work like this, so both of them is working until reaching to 180, 120, and then after reaching to 120, because the flow is 100%, so let's see now it goes down and the next cycle one compressor will work, but one compressor will not be sufficient to maintain the pressure or increasing the pressure. See, so the pressure now, instead of increasing into the tank, it is like decreasing. Okay, that's why it will not reaching to the way to switching to the other one. But if it is like this, if we're reaching to some point, like it is very slow to increase. Now both of them is working. Yeah, we need to reaching into the because I want to show you the case first before implementing solution for this case. So now it is like, as you can see, it will goes down, it will go down until 100, and once reaching to 100, so one compressor will working, as you can see here, and the pressure goes down. Okay, I want to show you how it might be very slow to change, like if it is like this. See, very slow to change. Okay, so the requirement, the new requirement here is to two things. The first thing is to measure the time for each one, measure the time for each compressor, how long it works, and displaying this value on this BCD displayment segment. And if you don't know about the how to using a 7-segment or BCD, so we have video already published in this series talking about the BCD, so you can saw this video to see how we're gonna implement it. It's very easy. Also to switching between A and B, A to showing the time for compressor 1 and B for compressor 2. This is the first requirement. And the second requirement, to monitor the time for each one, and if the time reaching to more than 8 seconds or 80 seconds, so at that time it will be switching will continue, okay, or running both of them to maintain the pressure again. So let's go getting started to make this implementation. So going down here, okay, and adding our new logic. So now in this rung, what we're gonna do is, like we need to have two timers, one timer for this that guy. So go into the timer here, and it will be retentive timer. And for sure we have a video for the retentive timer because we need to accumulate the value of the time, and we need another rung for the. We need another rung here for the other guy. I mean the other compressor. So here go on timer, retentive timer. So now we have two timer here. The first timer will be from this guy, as long as it is working. So, and this is for the second one, and let this one to be timer T40, and the other one will be timer T41. Okay, and set the value for very long time, and this also for long time. And this as long as this one is on, so the timer will count here, and as long as this one is on, so the timer will count here for this one. So now we can get the time as a timing for the first timer and the second. Also, we need to continue adding one rung to transfer this result to the screen. So here, moving to the rung, we need another rung here, moving this result to the screen. Actually, we need this rung. So we need the command for the moving to this. So we need this command for the to convert to BCD. So this conversion to BCD here will be done based on based on the switch A. So we have one switch here. So this one will be the switch, okay? And we need another rung also, like here. We need another rung, okay? And that rung also will be for the dot, which is converting to the this thing. So now this is the first one. So the first one will come in from this input, okay? And the other input will be here, okay? And what I'm gonna do here is to taking T4 dot accumulator from the source T4 0 dot ACC, and this is for the other guy. It will be T4 1 dot ACC, the accumulator. So I move the accumulator to this output. So this output is here. What is this output? I don't know if this output is Q4. Yes. So Q4, I don't know. Okay, I can make it like Q4 here, and also that guy will be to Q4 also. Okay. So here we are now to see the monitor of the process. So let's download this code and see what's the situation. So now I'm trying to run the code. So now the start is open. So once we're reaching to is this one to be like this. This is a flow. So this is a start. So now we're starting, okay, to count nothing, but if one of them is counting, okay, like I need to move it very fast for saving the time of the video. So now you can see reaching to 120, and then it will go back. Okay, it will go back, and once it go back to 100, so one of those will work, and the counter will count the time. Let's move forward to the time. So one of them now working, and the time is not count or what? Okay, let's see. Let's see why the counter is not working. The counter here is working already. Okay, for this and for that. So why? So now Q4 has a value. Okay, so this one is Q4, but I'm using a wrong. I'm sorry, I'm using a wrong one. So what I need to do is just to correct this output here to be 04. Okay, and the other one to be 04. Okay, and see. So now download and run the project. So we can start now. So you can see here the timer now showing the operation of each timer here. So now that timer, no one is working. Okay, you can see this is count like this value and this count for this value. Once it reaches 100, see this one is counting, but the other one, because it is not working, so it's fixed on this value. So now we have been displaying the value of the time for each one, of this compressor, the time for each compressor. So the last requirement is to adding a logic for stopping the running for long time for one of these compressors. So here quickly I'm adding this code for this part. What I need here is just like uh, if I have one of those, like if I have this guy or that guy, so I need a branch here. So if I have that guy, or I have the other guy, which is the second compressor, one of the compressors running. So this is one compressor is running. If that is running or that is running, okay, I will using one timer here. Go on timer T on. I'm sorry, T off timer. So forget about the T off. So I need T on actually. So moving this T off here, and we'll say this is T4 2, and we'll say this T on in the preset value will be like 80 seconds. If it is working for 80 seconds, so what happens is I will take this T42 right here to have the other one to working, or both of them to working. So I will put here a parallel branch for this guy, and like this, and that will be the timer. Okay. Okay, no problem. I will take this one here. So now this one is T4 2 dot done bit. Okay, the 2 dot done bit, and the same thing here I will make for the other guy. Like I will have this thing like this, and adding like that guy, and taking this timer here. So at any time the timer is done for one of them for 8 seconds. So what happens is it will be working. So let's test this last thing to make sure the requirement we received recently from our client is working. So guys, now let's run the project here. As you can see, we need to just clearing this value. We'll see. Oh, we didn't start or what? So now starting. Both of them is like, yeah. So now it is increasing until reaching to 180. And let's see, after reaching to down to 100, one of them it should be working. Okay, but I expecting both will be working. So this one is working. Let's see the time. Yeah, this one is counting the time, but that guy, because it is working without increasing the pressure, as you can see, the pressure is not increasing, so the time is going on. Okay, let's see its timer. Okay, because that guy, if the timer is on, so where is the timer? Because that guy working for a long time now. So the timer here, as you can see, counting until reaching to 80 seconds, and once it reaching to 80 seconds, action will be taken. See, 500, 600, and by the way, this is multiplied by the time base 0.1. So now 72 seconds, 73, 4, 75. Let's see what's going on here in the screen. Concentrate on the screen. After reaching to 8, see the other guy is working to maintain the pressure, and it will come back to normal when reaching to the 115. So now, as you can see, timer is resetted here, and it will go back to normal. Like this guy, when it reaching to 100, one of them will working. So I know this video is very long, but I hope you enjoyed it. And now you have a source for a complete project. Actually, this is one of the complete project we have done in the industry. So you can take it step by step and take your time, go through the rungs and write the code yourself and make the simulation yourself. And I hope, my friends, you enjoying every single moment. You practice and develop your skills in ladder logic programming. Thank you very much for watching, and I hope to see you again in the next video. Bye bye.